Can you see the presentation? Okay, so let me start today's class. I am Venkat Subbaradi, a research scholar at University of Hyderabad. So I am here to teach you some problems from assignment 6 previous years. So here is the first question. Actually, given a matrix A that you are watching 1 0 0 1 1 1 1 0 1. For this
Sir, you are
mat
not audible, sir.
sorry. Yeah, thank you. So this is the matrix given A equal to 1 0 0 1 1 1 1 0 1. The first three questions are for this matrix only. Whatever the questions it is. Okay. So the first question is the generalized eigenvectors of A are given as. We have to find the eigenvectors for this matrix. That is easy. I think you all know how to find. So the matrix is 1 0 0 1 1 1 1 0 1. Let me solve this. Today's date 6/9. So the first problem is given A equal to 1 0 0 1 1 1 1 0 1. So for this they ask the generalized eigenvectors. Can anybody guess what are the eigen values for this matrix by just looking at this matrix? Can anybody say?
तो करेक्टर पॉलिनोमियल से निकलेंगे.
Yes, okay, that's okay. But can you just guess the eigenvalues for this matrix without that characteristic polynomial? Of course, the characteristic polynomial,
1.
yes, is equal to the determinant of the matrix x minus 1 0 0 1 x minus 1 0. Sorry, this is 1 1 0 x minus 1. So can you tell me what is this polynomial? This is nothing but x minus 1 whole cube. Those are eigenvalues are 1 only.
1 1 1.
Yes, eigenvalues are 1 comma 1 comma 1. So am of the eigenvalue 1 equal to 3, that algebraic multiplicity. Somebody is waiting. So let's find that eigenvector for this matrix. So how to find? We have to consider a minus I, because the eigenvalue is 1 into x is equal to 0. We have to find the solutions for this equation. So a minus I times x. This matrix is nothing but 0 0 0. We get 1 0 1 0 0 0, I think, from the given matrix. Yes, here it is 1. So times x is nothing but the column vector x1 x2 up. We will take x y z. This is equal to 0 0 0. By just solving this equation, these three equations, we get one eigenvector. That is, from the second row we get x plus z equal to 0. From the third row we get x equal to 0. That implies z also equal to 0. So we have no idea about, we have no information about y. So for that y we consider 1. So the eigenvector is x is 0, y we don't know, so we are considering it as 1. That means for any value of y, this equation will hold. That means this equality, that is equal to 0, holds. But the values for x and z has to be zeros only. That's why the reason we are taking 1 here. But actually the algebraic multiplicity for the eigenvalue 1 is 3, but we get only one eigenvector. That implies gm of 1 equal to 1, but we have to get 3 eigenvectors. Can anybody tell how to find the other 2 eigenvectors?
सर सेम करेक्टरिस्टिक्स पॉलिनोमियल लेके उसको हम इस जो अभी आपने निकाला आइगन वेक्टर उसके बराबर पुट कर देंगे.
Yes,
ए
how to
आई
consider?
माइन
Yes,
एक्स आई इक्वल टू जो अभी आइगन वेक्टर निकाला उसके बराबर
yes,
0
0
1 0.
1 0. By solving this equation we get another eigenvector. That implies this matrix is 0 0 0 1 0 1, this 1 0 0 times x y z equal to 0 1 0. So this, again these equations are nothing but x plus z equal to 1 and z equal to 0. That implies z equal to, sorry, x equal to 1, right? X equal to, sorry, this is z, x equal to 0. Yes, so we get z equal to 1. So the eigenvector is,
0
so the
1
eigenvector
1.
x is 0, we have y equal to 1, z equal to 1. So we got one more eigenvector. So from this again we have to find the third eigenvector. The process is same. We have to consider a minus I times x equal to the eigenvector whatever we get now.
0 1 1.
Yes. By solving this we get another. Somebody is raising hand. Yes, any doubt?
Yes, sir. I have a doubt in other
Yes,
question.
yes.
Please, you can complete and then.
Sorry, can you speak loudly? I cannot hear you.
Sir, I have a doubt in other question.
Other
Please,
question?
yes, sir.
Yes, yes, please.
Can I ask?
Oh, can you wait for 2 minutes? Let me complete this problem.
Yes, sir. Yes, sir. Okay,
Okay.
fine.
So these equations will become 1, sorry, this is 0 0 0 1 0 1 1 0 0. This is xyz. This is equal to 0 1 1. So by solving again these three equations we get y plus, sorry,
X.
x plus z
So
equal
x
to,
plus z equal to 1.
yes, and x equal
X
to
equal to 0 1.
one,
Z is
So z
equal
equal to
to
0
0. So the eigenvector is, so
1 0 0
110.
1 1 0
1 1 0.
0.
So the generalized eigenvectors are the second and third eigenvectors. That is 0 1 1 and 1 1 0. That is the correct option. 0 1 1 and 1 1 0. The first option is correct. Is it clear or anybody have any doubt in this problem?
So clear.
That
No,
person,
sir.
yeah, that person,
Yes, sir. Yes, sir.
yeah,
Yes, sir. I have cleared in this problem, but I have a doubt in other problem. Can I
yeah,
ask
tell
you?
me, yeah, ask me.
Okay, sir. If we have given a matrix A is equal to 3 by 2 matrix,
A is 3 by 2 matrix.
yes, sir. A is equal to there is a US V transpose in singular value decomposition of A
Okay, U, yes,
and
V transpose.
V
Okay,
transpose, and where U is minus 1 by root 2.
U equal to,
U is a matrix of 3 by 3 order.
okay,
Minus 1 by root 2, 1 by root 2, 0,
minus 1 by root 2, 1 by root 2, 0.
0.
Yes.
And the second row is 1 by root 2, 1 by root 2, 0.
Hmm.
And third row is 0, 0, 1.
Okay.
And then S is my S is 3 by 2 matrix, 2, 0,
2, 0.
0, 1,
Okay.
0, 0.
Okay.
And then V transpose is equal to minus 1 by root 2,
Okay.
minus 1 by root 2.
Again. Okay.
Yes, yes, sir. And then second row is minus 1 by root 2,
Okay.
and then plus 1 by root 2.
Okay.
Then we have to find the pseudo inverse of A.
Okay.
And I have to complete means I have to means we have to calculate the pseudo inverse of A. I find it, but this the option is not matched with the any
We
of
have
the option.
we have to calculate this.
Yes, sir. Yes, sir.
Actually, we have one problem of this same kind in this assignment also. We will solve that. Actually, this is nothing but, if you are following the class notes, we can easily
Yes,
get
sir.
this
Yes.
is nothing but V S plus and U, where S plus is nothing but S plus is equal to, we'll just simply get 1 by 2, 0. Yes. No, no, no. 1 by 2, 0, 0, 0, 1, 0. This is S plus. If you multiply with
And
the,
this is
the
S transpose.
yes,
Same means S plus is same as S
S
transpose.
plus. Yeah. No, no, not same
Oh,
as. In S plus, we have to rationalize the, we have to rationalize each non-zero
okay.
element,
Okay.
and we have to
Okay.
do the
Okay.
transpose. This is
I
S
understand.
plus. If you
I
now,
understand.
if you calculate the product, this product, you will get the pseudo inverse.
Okay. Okay.
Is that the way
Then,
you did, or any?
sir, I have to calculate like that. X means A transpose A whole inverse into A transpose, but this
Oh,
doesn't match.
okay.
Can you,
You just do this problem. You will get that. Just do this
okay?
multiplication, and then you will get the answer.
Means I have to find the V is given,
V is
V is
given.
given,
Yes,
H
yes,
plus is given here, and U is given. Then I have to just multiply and then get the
yes,
answer.
yes. V is,
And
yes,
सर
in,
ये S प्लस कैसे निकाला है बताना.
S plus. Okay. So
Yeah.
given S is that 2 0 0 1 1 0 1, sorry, 0
yes,
0. So we have to just rationalize the every non-zero vector. This is S plus is equal to, we have to rationalize. That means, that implies rationalize is nothing but we have to do 1 by whatever the non-zero element. Rationalize non-zero element. That implies what we get is, we get 1 by 2, 0, 0, 1, 0, 0. The transpose of this matrix. This is nothing but S plus. Is it clear? If you see
Yes
that
sir.
class notes or class videos presentation, you will get how to do this. This is a direct problem. Yeah, you just do the this product V S plus U, then you will get the answer. This is a simple.
Okay, sir. Okay.
okay,
Okay.
okay, sir. I have in one other doubt.
Yeah, yeah, please.
Yeah. The non-trivial solution of A transpose X.
Okay.
Please tell me how
A
we
transpose X.
the non-trivial solution of this system.
Okay. What is the matrix A?
A is as decomposed in the above as given
The
in the
same
above.
matrix.
Yes. Yes.
Okay. U S V transpose. Then you can simply multiply all the matrices and I mean this product, and do that, solve this equation. You will get that answer. Do you get it?
Sir, A plus is given. Means how we get the A transpose?
A plus is given.
Sorry, how we
A
get the A is
here
given.
A is given.
Yes, sir. A
A
is
is
given
nothing.
in form of decomposition of three matrices.
Yes, you just multiply these three matrices, then you will get A.
Uh-huh.
From that you do A transpose, you will get 2 cross 3 matrix.
Okay.
Just take x y z. A is
Okay.
A transpose is 2 cross 3 matrix, so you have to take 3 cross 1 matrix X, that you make
A
that is
column,
equal
a
to
column,
0.
a
Yes,
column vector, and
yes.
then
You make the that is equal to 0, then you will get some equations. You just solve them, those three equations, you will get the answer.
thank you.
I think these problems are current assignment problems.
Yes, sir.
Yeah.
I have doubt in this
Okay. Okay. This
question.
is the process how to do. You just try. Otherwise,
Okay, sir.
after the
Okay, sir.
due date, you will get the solutions.
Okay, sir.
Okay. So the matrix here, actually that kind of problem. Yes, here it is the sixth problem. Here also given A equal to some product of three matrices, and it is asked to find the pseudo inverse. If you have time, we will solve this. So the second problem here is the matrix A power 50 is equal to, for the given matrix only A. So let me do this. Actually, we don't calculate A square. We don't calculate the up to A power 50. We will just calculate A square and A cube. Then from that we will get what is A power 50. So given A is equal to 0 0 0. So here it is 1 1 1 1 1 0 1. From this, just you calculate A square, A cube, and if possible A power 4 also. Calculate this. From that you can get what is the value of A power n. Let me do that. So A square is equal to 1 0 0 1 1 1 1 0 1 1 0 0 1 1 1 1 0 1. This is equal to this is equal to 1 0 0. Here we will get 3 1 2. This is 2 again 0. This is 1. Yes. Then next calculate A cube. I am just writing directly. A cube is nothing but 1, just by doing the multiplication with A and A square. We will get this is 0 0. This is 1 plus 2 plus 3. Here 1. Here 1 plus 2. Then 1 plus 2. Here 0. Here 1. So if you observe the A square matrix, this is also similar to this. How? 1 0 0. This is 1 plus 2. This is 1. This is 1 plus 1. This is again 1 plus 1. This is 0 1. So similarly, we will get for A power 4 is nothing but 1 0 0. Here we will get 1 plus 2 plus 3 plus 4. Here 1. Here 1 plus 2 plus 3. 1 plus 2 plus 3. 0 1. From the similarity, we will get A power 50 is equal to 1 0 0. Here we will get 1 plus 2 plus and so on up to 50. 1 1 plus 2 plus and so on up to 49. Here also 1 plus 2 plus and so on up to 49. Is it 49? No. Just let me calculate the value of A power 4, then we will get some idea. So the first row is 1 0 0. The second row is, we'll get a into a cube. What we'll get? Here we'll get 1 plus 2 plus 3 plus 4, 1. Here we'll get 4 only. Here again 4, 0, 1. This you just check, just multiplying a with a cube. So from this we will get similar, by the similarity we will get this is 49. So this is 50, this is 50, this is 0, 1. So we have the formula for first natural number, for first n natural number, that is nothing but n into n plus 1 divided by 2. From that we get this is equal to 50 into 51 by 2, that is nothing but 50 into 51.
Sir, will you please again tell me about a power 50 once, please?
Yeah, 1 minute. This is 50, 0, 1. This is 1250. So if you observe the matrices A square, A cube and A power 4, so in the A square matrix we get this. So let me compare A square with A cube. So in the A square, in the matrix, in the every matrix A power n, we get these diagonal elements are ones only, and these three elements are zeros only. We have to think about the rest of the three elements. In the A square we get this is equal to 1 plus 2, and for A cube we get 1 plus 2 plus 3, and for A power 4 we get 1 plus 2 plus 3 plus 4. Likewise we get for A power 50 we get 1 plus 2 plus and so on up to 51. That's how this element is. And for the second to third row, this A2 3, we get for A square we get 2 only, for A cube we get 3, and here also for 3. For A power 4 we get 4 here, and here also 4. Similarly for A power 50 we get 50 and 50 in these two elements. This is how I wrote A power 50.
Yes, sir. Thank you.
Just by simply comparing the matrices A square, A cube, A power 4, we will get this.
Thank you, sir.
So this is the matrix A power 50. The answer is answer is option B is correct. So the third problem is the minimal polynomial of A is. This problem can be done from the calculations of first problem only. Let me tell you. So the third problem is minimal polynomial of A. X, the minimal polynomial of A. So the from the first problem, what we have, geometric multiplicity is equal to 1. In the last class I told you that geometric multiplicity is nothing but the number of Jordan blocks. Here it is, A is given that 3 cross 3 matrix. So the JCF also is of order 3 cross 3. And we have the geometric multiplicity is equal to 1. So the number of Jordan blocks corresponding to the eigenvalue 1 are 1 only. That means the JCF is nothing but 1 1 0 0 1 1 0 0 1. Is it clear how to write JCF? Firstly, if you understand this, we can get the answer for minimal polynomial. Is it clear, or shall I explain again?
Will you please again explain, sir?
Yeah. So for we have that JCF has to be in the diagonal elements, we have to write the eigenvalues only. That means 1 1 1. These are the eigenvalues, and the below diagonal elements has to be zeros. In the above diagonal elements we have to think, because it is given here that geometric multiplicity is equal to 1. That means it can have only one Jordan block. That means in Jordan canonical form we have that either this equal to this element is equal to 1 or zeros only. So if we write 0 here, we will get this is equal to one block, and this two element, this whatever the element here it is, if you write 0 we will get 3 blocks, or if you write 1 we will get 2 blocks, but we have only one, it has to be only one block there, so it has to be 1 here only. This is how I wrote 1 here, and this has to be 0 anyway. And for here the second row third column, that element, if you write 0 again here, it will become 2 blocks, like this is one block and this is one block, but then it will become 2 blocks, but we have that geometric multiplicity is equal to 1, so it cannot be 0 here, it also has to be 1. So this is how JCF form is written. Is it clear?
Yes, sir.
Yeah. Actually the number of possibilities for Jordan blocks are, let me write. So there can be 3 possibilities, that is 1 0 0 0 1 0 0 0 1. Let me write clearly. Possible JCF are this one, and the second matrix is 1 0 0 0 1 1 0 0 1. This is another block, and the third matrix is 1 1 0 0 1 1 0 0 1. These three are the only possible Jordan canonical form whenever the eigenvalues are repeative and of AM3. But here it is, we have another condition that geometric multiplicity is equal to 1. So from this, among these 3 matrices, if you observe here, the geometric multiplicity for this matrix is equal to 3, because we have 3 Jordan blocks, and here geometric multiplicity is equal to 2, because we have 2 Jordan blocks, this is 1 and the above is 1. That is not correct. So for this matrix only we have geometric multiplicity is equal to 1. This is how JCF is written. Is it clear now?
Yes, sir.
Yeah, somebody raised the hand, I think. Nobody?
सर
Yes, please.
ज्योमेट्रिक मल्टीप्लिसिटी 1 दी है क्या?
Yes, that is from the problem, first problem, because here it is when we solve the first equation a minus I into x equal to 0, we get only one eigenvector. That implies the geometric multiplicity is 1. The number of eigenvectors we get, that is nothing but the geometric multiplicity. Yes, some other raised the hand. Is it clear, or you still have any doubt?
क्लियर सर.
Okay, everybody, is it clear?
Yes sir.
Yes, sir. But in the first question that I have asked later, means in the previously,
Yes.
in this sir, U transpose, we can say that the rank of A and the rank of S, I think both are the same, right?
Both are same. Yes.
Okay. If the rank of A is 2, then S is also 2, and if S is 2, then A is 2,
Yes.
right?
Yes. Yes.
Okay, thank you.
And if you observe, U and V are orthogonal here.
Orthogonal matrix.
Yes. That is one important property here. So from this, so yeah, problem is not over yet. So we just got the JCF. So now you get the order of the highest Jordan block. This is the Jordan canonical form, the matrix, this one, and the order of the highest Jordan block in this matrix is nothing but 3. In the last class I told you that the order of the highest Jordan block is nothing but the degree of the minimal polynomial. Therefore minimal polynomial of A is nothing but x minus 1 whole cube. This 3 is nothing but the order of the highest Jordan block, that is nothing but 3. If suppose the first matrix here, suppose this matrix is the JCF, then we will get minimal polynomial is nothing but x minus 1 x minus 1 only. For this matrix, we will get minimal polynomial is equal to x minus 1 whole square, because the highest Jordan block, order of the highest Jordan block is 2 cross 2. We have here the Jordan block is of order 2 cross 2. So minimal polynomial should be x minus 1 whole square. Is it clear?
Yes, sir.
Sir, how the order of the Jordan canonical form is 3, sir, here? Can you please explain?
Yeah, nothing but this one. So how it is 3? Actually the order can be defined like this.
Because we can say that na, sir, कि,
Yes,
if the minimal polynomial power has a power 3, then there must be a GC block of order 3 for corresponding lambda. So there must be a JCF, means Jordan canonical form of lambda is equal to 1 for lambda
yes,
is equal to 1.
yes. Actually, this is a direct question. When we look at the matrix, we have to think of this kind of sub matrices. In the second matrix, I am writing here. When we look at this matrix, we have the Jordan canonical form is of the order of the block is 2, because we have the element 1 beside 1. This is eigenvector eigenvalue. The if the element beside the eigenvalue is 1, we have to consider that in Jordan canonical form. This is a just direct problem, direct question. If you follow the classes, we can understand this how it is.
Okay, sir.
You just have to think the element beside the eigenvalue. Here these three are the eigenvalues. We have to think of the elements beside the eigenvalues, these two elements. From that only you will get the order of the block.
Okay, sir. Non-zero values, sir.
Yes. No,
Oh.
not actually non-zero. In JCF, these two elements has to be ones only.
Okay, okay.
These two elements has to be one, and of course the eigenvalues may change.
Okay, okay, sir. Thank you.
So this is about third problem. Somebody raised the hand, I think. Any doubt still?
No, sir.
Okay. So the fourth problem here, it is given a matrix A and it is asked to calculate e power A. The matrix, yeah, let me explain something here. Here if you see, this matrix is also in JCF form. That is, we have that these three are eigenvalues for this matrix 3 3 4, and this element is non-zero. That means this we have 1. But for the matrix, for the eigenvalue 4, we have 0. We have only one block, that is this block only. But for the eigenvalue 3, we have a block of order 2. So for this, I can say the order of the Jordan block corresponding to the eigenvalue 3 is 2, because this is 2 cross 2 matrix. This is how it is.
Oh, it is 2, correct. Okay,
Yes.
sir. Number of Jordan blocks are 2.
Yeah, number of Jordan blocks are 2, and the order of the Jordan block corresponding to the
Is 2.
eigenvalue 3 is 2.
Okay. Okay.
So from this, I can say the minimal polynomial for this matrix is x minus 3 whole square into x minus 4. This is the minimal polynomial, and of course this is the characteristic polynomial also. This is nothing but, this 2 is nothing but the order of the Jordan block corresponding to the eigenvalue 3, because here we have the Jordan block of order 2, so I'm just writing 2 here. And for the eigenvalue 4, we have only one order, only one this block and of order 1, so I'm just writing 1 here only. This is how minimal polynomial comes from JCF. But the question here, it is different. So it is asked to calculate the e power A. So for this matrix, we will just simply calculate a square, a cube, and so on. From that, we can get e power a. So the given matrix A is equal to 3, 1, 0,
Sir,
0,
we are calculating e power a, you just using the pattern, is it? For the previous one also, a to the power 50, using the
yes,
pattern only we wrote. Is
yes.
it a general method or is it applicable only to that particular matrix?
No, no, it is not a general method. It is applicable for some matrices only.
Oh, then if
Actually,
the matrix is different,
actually, we have to calculate a square, a cube, and a power 4, and so on, all are all. But for this kind of matrices, we'll get some pattern for a power n.
okay.
We'll get some pattern like for each element, we'll get some pattern. For
Because
different,
our assignment question, A is different, sir. Do we have to find out what is the pattern, is it?
yes,
To,
yes, that is
oh,
the question. We have to find the pattern for each element.
but it is
Then we
not
have to sum
fixed.
up.
It is not fixed.
No, it is not fixed.
Okay, okay, thank you.
For different matrices, we'll get different pattern.
Okay, sir,
Even
thank
for
you.
some matrices, we may not get any pattern.
Oh, then what do we have to do then?
We have to sum up each element, and we have to calculate each matrix, and we have to sum up them. Of
If
course,
it is
that is,
a to the power 50, how can we calculate, sir?
yeah. If we get any pattern, that is okay. If we don't get, we have to keep calculating a power 50, a power 100 also.
Okay,
But such kind of matrices will not be asked in.
okay, sir. Thank you.
So we get we write yes, we calculate a square. This is 310,030,004 into 310. Yes, any doubt?
No, sir, by mistake.
Okay.
Sir,
So this is,
question was find e
yes,
power a,
please.
na?
Yes, it is asked to calculate e power a. But we have the formula that e power a is equal to I plus a square by 2 factorial plus a cube by 3 factorial plus and so on. We have this formula. So I'm just calculating the values a square, a cube, and so on. From that, we can get some similarity for a power n.
Okay, sir.
So we'll get this here 9. Here we'll get 3 plus 3. Why I'm writing here 3 plus 3 is if we write 3 plus 3 here, then we can get the some idea for the pattern. What is the pattern it is coming here? If we write simply 6, we don't get, we may not get the idea. That's why I'm writing 3 plus 3 here. Yeah, I'll tell you why it is clearly. If you write for a cube, then you will get some idea why it is. This is 0, this is 9 again, this is 0, 0, 0, this is 16. If you observe the diagonal elements for this matrix, these are nothing but the squares of the diagonal elements of the matrix A. That these are nothing but 3 square, 3 square, and 4 square. And for this 3 plus 3, if you observe, this is nothing but 2 into 3. Yeah, any doubt? Somebody is raising the hand, I think. They are left. Okay. So for a cube, what we will get is, here we will get 27, here we will get 3 plus 3 plus 3. 0, 0, 27, 0, 0, 0, 64. From this again, if you observe the diagonal elements, these are nothing but the cubes of the diagonal elements of the matrix A. That these are nothing but 3 cube, 3 cube, and 4 cube. And the second element, this element is nothing but 3 times 3. That is whatever the power here we are using. This number times 3. For the A square matrix, we get 2 into 3. That is the pattern we are getting. Similarly, for a power n, we get for a cube. Is it correct? I think for a cube it is not. that one. 3 1 0. No, this is not 3 plus 3 plus 3. This will get 3 times 3 plus 3 plus 9. This is not n into 3. So can anybody tell what is the pattern here? For a square we get 3 plus 3. For a cube we get 3 plus, we get 9 plus 9 plus 9. Can anybody tell what is the idea? This is for a square, this is for a cube. Similarly for a power n, what can we get?
Here we are squaring the I think in the a square this a12 element will
Yes,
3 power 1 plus 3 power 1. Here 3 square plus 3 square plus 3 square. That means here we are adding 3 times. That means in a cube here we are playing.
yes,
So that's
yes,
why here 3 times we are adding the 3 square.
yes.
3
So
to the power n minus 1 plus 3 to the power n minus 1 up to n times.
yes, this is nothing but 3 power 2 minus 1 plus 3 power 2 minus 1. Here it
2
is 3 power 3 minus 1 plus 3 power 3 minus 1 plus 3 power 3 minus 1.
So it is n
For
into
a
3
power n, we
minus
will
1.
get, yes, n times 3 power n minus 1 for the matrix a power n. And the diagonal elements are nothing but the nth powers of 3
3.
3 3 n. That means a power n is nothing but 3 power n, this is 3 power n, this is 4 power n, and here we will get 3 power n minus 1 times n. This is 0 0, all the elements are zeros. Is it clear how to generalize the matrix a power n?
Yes, sir.
By just observing the matrices a square, a cube, a power 4, we will get some idea. If they are asking this kind of matrices, there should be definitely some pattern. Otherwise, they will not ask. Somebody,
Sir, so can
yes,
we say that if there is no pattern in the matrix and if we convert it and the matrix is itself is non-diagonalizable, then it can be converted into means if the matrix is non-diagonalizable, then it can be converted into JC form, and then the corresponding JC block
yes,
corresponding to the GC block, we can find the power of these blocks. And is there any relation between these JC block powers and the original matrix?
yes, yes, yes.
Because these
Actually,
two matrix are similar and the similar matrix has the
yeah, okay, let me complete this problem and I'll explain that how to calculate. So this is a power n, so we get e power a is nothing but this is nothing but I am just adding I a square by 2 a cubed by 3. So just writing the elements of those matrices, we get 1 plus 3 plus 3 square by 2 factorial plus and so on. And the second element we get, what is this element? 1 plus, for the matrix A we have 1, for the matrix A square we have 3, for the matrix A square no, 3 plus 3, this is nothing but 3 into 2 divided by 2 plus, for the matrix A cube we get 3 square into 3 divided by 3 plus and so on. This is 0 0, this is again 1 plus 3 plus 3 square by 2 factorial plus and so on. This is 0, this is 0 0, 1 plus 4 plus 4 square by 2 factorial plus 4 cube by 3 factorial plus and so on. Here we will get 3 cube by 3 factorial. So from this, can anybody tell what is the matrix? This is nothing but e cube.
E to the power 3.
Yeah. So yeah, we will think about this element, what it is. So this element is 0 0 e cube, this is 0 0 0 e power 4. We have to think about that element, the first row second column element, that is nothing but 1 plus 3 into 2 divided by 2 plus 3 square into 3 divided by 3 plus and so on. This is nothing but if we write in summation form, we will get this is equal to summation n equal to 0 to infinity 3 power n into n divided by n factorial. Here it is n minus 1. Is it correct? No. For n equal to 1, we will get this is,
Correct, sir.
I think 3 EP3.
it has to be no, for this is
N is
1
equal
1 plus, yeah,
to correct.
for the first n equal to 1 we get 1 divided by 1 factorial. N equal to 2 3 square 3 into 2 divided by 2, yeah, okay, here it should be 3 factorial. Yes, somebody is raising the hand or they are leaving. I'm getting some sound. Okay, they are leaving.
Sir, will you please again explain from e power a?
E power a, okay, e power a is nothing but the sum of the matrices I plus a square plus, sorry, a square by 2 factorial plus a cube by 3 factorial plus and so on. So I'm just adding the matrices 1 0 0 0 1 0 0 0 1 plus a is nothing but 3 1 0 0 3 0 0 0 4. For a square we get, of course, 1 by 2 factorial should be there. 1 divided by 2 factorial into 9. This is we get 3 into 2 0 0 9 0 0 0, this is 16 plus and so on. And I just wrote the sum of these matrices here, and then I'm just calculating the value of each element. The first element is nothing but e cube. Of course, I'm just calculating the second element, and the diagonal elements are e cube and e power 4. Is it clear?
Sir. Yes, sir.
So from this summation, if you observe, what is this? This is 1 plus summation. Let me write in next line. This is equal to 1 plus summation 3 power n minus 1 into n minus 1. Sorry, this we don't get 3 power n minus 1 by n minus 1 factorial. N is running from 1 to infinity. I'm just rewriting this is equal to 3 power n divided by n factorial, and n is running from 0 to infinity. Do you observe these two summations are same? Do you agree?
Yes, sir.
Sir, yes, sir.
Yeah, you just express, you just expand the two sums, then you will get how it is. So from this I can say this, the second element is nothing but e cube again. So this is also e cube again. So this is nothing but e power a. That is what it is asked to calculate. So e cube, option B is the correct option.
Sir,
Yes.
e power to finding the e power a method is to common to all matrices, sir. If
Yeah, it is.
If a has different
No, it is.
eigenvalues.
If you have different eigenvalues, yeah.
If
Please come.
if your given matrix have a different eigenvalues, can you do solve by this method, sir?
Yeah, let me tell you that how to calculate. Suppose A is given some matrix. For this matrix, we can write the JCF form. A equal to some P times J P inverse. This is the matrix. For this corresponding J matrix, we can find easily J square, J cube, and so on. Because it will be in JCF form. That is some simple form, some simpler form than A. From this we get e power a is nothing but P times e power j P inverse. Here for e power j it is easy to calculate than for, I mean, for other matrices. If A is difficult to calculate a cube a power 4 and so on, then we will use this process to calculate e power j. From that we can just multiply p e power j p inverse, then we will get the matrix e power a. If a is given some simpler form, then we can directly calculate a square a cube and so on. Of course, in this method also we have to calculate j square j cube j power 4 and all. But when a is difficult, we will get for some simpler matrix for j, then we will use this method. Is it clear?
Yes, sir. Thank you, sir.
When a is given some difficult matrix, when it is difficult to calculate a square a cube and so on, then we use this method. Then in that case it is easy to calculate j square j cube because that will be in JCF form.
If A is diagonalizable, then we can write it as P dP inverse, na? And from that, I think it is easy to calculate.
Yeah, if a is diagonalizable, we'll simply get that p lambda 1, this j is nothing but the diagonal matrix and so on lambda n into p inverse. Then we will get a power n is nothing but p times lambda 1 power n, lambda 2 power n and so on lambda n power n, all the diagonal elements these are, this into p inverse. From this we can simply get e power a is nothing but e power lambda 1 e power sorry, in the should be in diagonal, e power lambda n. If a is diagonalizable, this is the matrix e power a. Is it clear?
Yes,
P
sir.
this matrix into P inverse, na? So
Yeah, whatever it is, if you take p inverse equal to q, then I can just simply, this can be replaced as q inverse some matrix into q. That does not matter. P times p pj p inverse or p inverse j p, whatever it is. Is it clear?
yes, sir.
Yes, sir.
Okay.
Sir, I have a doubt, sir.
Yes, please.
Sir, you write this matrix, sir.
Okay.
2, 1, 0, 0, first row.
2 1 0 0. Okay.
0, 2, 1, 0.
Okay.
0, 0, 2, 0.
Okay.
0, 0, 0, 3.
Okay.
So here the number of Jordan blocks, is it 2, sir?
Yes, number of Jordan blocks are 2.
And now order of the Jordan corresponding to 2, is it 3?
Yes, 3. This is one block
Okay.
and this is another block.
That block. And corresponding to this eigenvalue 2, it is 3. Order is 3.
Yes, yes. And its minimal polynomial is nothing but?
X minus 2 the whole cube into x minus 3.
Yes. And this is the characteristic polynomial also.
Also. Okay. Thank you,
Yes.
sir. Okay.
Yeah. Explain, sir. Sir,
Yes. Where's the cursor? Yes, any doubt?
sir.
Sir, sir,
Voice
I
is,
have a wonder, sir.
yes, please.
If A matrix and then the Jordan canonical form of that matrix are same, sir.
Yes, okay.
If the matrix have a matrix and Jordan canonical form of the same order, sir.
Okay. Those two can be same.
Same. Okay, sir.
Yeah. Suppose you take that JCF form as again some other matrix, then you will get the same matrix as JCF form for the same, for that corresponding matrix. Actually, for this matrix, this is the JCF form, and this, if you actually this is in JCF form. If you find the JCF form for this matrix, again you will get the same matrix only.
Thank you.
Okay. Yeah, somebody earlier was asking. Your voice was not
What
clear.
is that, sir?
Yes, your voice is not clear.
Jordan blocks.
Okay. Doubt? What is the doubt? Hello. Your voice is not clear, ma. I cannot understand your question, your doubt.
Please explain again the Jordan block, sir.
Explain means for
Jordan
this
block.
matrix.
Yes, sir.
Yeah. So the given matrix is 2 1 0 0 0 2 1 0 0 0 2 0 0 0 3. Firstly, you have to think about the diagonal elements. You have to look at these diagonal elements and then look at the next element to the diagonal elements. If this is 0, then we can consider this element only one block. If suppose this the next element to the diagonal element is non-zero, then we have to go to the next row, because here it is non-zero, so we have to go to the next row. If in the next row again, if the next element to the diagonal element is 0, then we have to consider this submatrix as one block. Suppose this is non-zero again, that means the element next to the eigenvalue 2, that is non-zero, then we have to go to the next row again. If suppose here it is 0, because this element is 0, so we have to consider this submatrix as a Jordan block. If
Your
suppose
screen, your screen is not visible.
not visible,
No, sir, the screen is visible, sir.
yes,
The
it is,
visual.
yes, it is presenting.
Yes, sir, it's presenting, sir.
Yeah. So in the third row, the next element to the diagonal element is 0. So we have to consider this 3 cross 3 matrix as one Jordan block. Suppose if this is non-zero and suppose there is 1 here instead of 0, then we have to go to the next row again. Of course, in that case there should be 2 here, because 0 is there, they are replaced with 3. That is how we have to calculate the order of the Jordan block. Is it clear now?
Yes, sir.
Time is almost over. So I'll just show you the question. You can ask me what you need to solve. What you want me
Sir,
to
for
solve the
this
problems.
matrix, sir, for this matrix, explain a e power a, sir.
E power a.
Yes, sir. For this matrix, 2100.
You just calculate a square, a cube, and a power n. Then you will get some pattern similar to that this matrix. I think you will get here. You will get 2 power n, 2 power n. Here also 2 power n. This is 3 power n. Here you will get 3 power n minus 1 times n. Maybe here also, here it may be the same 3 power n minus 1 into 3, or 3 power n minus 2 into 3. Sorry, here n. This we have to check. You just check whether there can be two possibilities here. I am not sure. If you calculate the values, if you calculate a square a cube for this matrix, we will get some idea. Here either it can be 3 power n minus 1 into n, or 3 power n minus 2 into n minus 1. Any one of this can be possible. You just calculate and just observe.
Sir, will you please just tell me about the singular values finding for the matrix?
Okay. Singular values are nothing but square
Square root
root. Yes,
of eigenvalues.
square roots of eigenvalues of A into A transpose. Not to the matrix A. It is to A into A transpose. These are the singular values.
Yes, sir. Thank you.
So for this matrix, if you multiply A into A transpose, you will get some diagonal matrix.
For
for this
singular
method.
value,
Yes.
can it be equal to eigenvalue also if it is equal to 1?
What singular value? Yeah. In that case, if it is
Usually
1,
singular value will be less than eigenvalue, right?
yeah, yes, because it is square root.
Yeah, it can also be equal to,
Yeah, when
less
it,
than or equal to
yeah, it is always less than or equal to eigenvalue. That
eigenvalue.
eigenvalue. Yes.
Okay, thank you. Sir,
For
one
this,
question in the assignment which is given to us,
okay,
question number 10, conditional number, calculating conditional number. I think the options, not yours, sir, ours.
okay, okay.
Ours question, I think the options given is not matching, sir. Conditional number is just, it is norm of A into norm of A inverse, right?
Yes, yes. Norm of A.
It is not matching, sir, the answer which is given.
The
Yeah,
answers are not
there is
The
another method also.
I know. That is maximum value.
Singular
Yeah.
value. Yes, yes.
No, no,
Sigma.
no, sir. No, it is not matching, sir. The answer, the options which are given to us
Okay.
is not matching. You please look into it and just get back to us, sir.
Okay. If the answer is not there, then don't worry. That question cannot be calculated,
Oh,
evaluated.
okay.
You just need the how to do that problem,
No, that
not
yeah,
the
that
score.
conditional number for that is 7, but that 7 option is not there.
Okay.
same here.
Yeah.
Okay. If your answer is not there, just leave it. That problem cannot be evaluated.
Okay. Okay. You just bring it to the notice of the people, sir.
Okay. Okay.
Thank you.
Okay. And in the last class, somebody was asking one doubt about the symmetric matrix, the orthogonality of the eigenvalues for a symmetric matrix. Is that person is there? Suppose A is symmetric, that means A is equal to A transpose. Then the eigenvectors corresponding to different eigenvalues are orthogonal. The person was asking the eigenvectors for same corresponding to the same eigenvalue are orthogonal or not. It need not be orthogonal. Suppose is that person is there? Okay, let me explain anyway. Suppose we have taken some matrix. Let me take 1 2 1 1 0 0 0. This is diagonal matrix, and it is of course this symmetric matrix. So its eigenvalues are nothing but 2 1 1. For the eigenvalue 1, we have for eigenvalue 1, the eigenvectors are we have the eigenvectors 0 1 1. This is one eigenvector, and another vector is 0 0 1. These two are eigenvectors for the eigenvalue 1, but these two are not orthogonal. From this we can say the eigenvectors corresponding to same eigenvalue need not be orthogonal. Is it okay?
Yes, sir.
Okay. So I think the time is over.
I have a small doubt, sir.
Yeah, please.
How can we find the non-trivial solution for the matrix A transpose into X is equal to 0?
Non-trivial is nothing but not the 0. Actually, if you take A transpose into 0, this is always equal to 0. Do you agree with this? If you take X
Yes,
equal to
sir.
0, this is equal to 0. Non-trivial is nothing but the non-zero solution. You don't get, I think. Suppose X equal to some x1, x2, and so on, xn. If you take these values,
Here the matrix here will be given, sir.
Okay, then you just solve the equations. You will get some values for x in that vector. If you get the values for each value are zeros, then then it will be the trivial only. You should try for non-trivial. That means you should get some non-zero values for at least one value.
Okay, sir.
Any more doubts?
No, sir.
If you have no doubt, we can leave.
Sir, the remaining questions in your assignment, no, sir, please solve it and then post it together. Because
Okay.
we have not solved all the questions.
Yeah. Okay, I'll just write the solutions and.
Yeah, post them together, sir.
Okay.
Thank you.
Thank you.
Thank you, sir. Thank you so much.
Thank you,
Thank you,
sir.
sir. Thank you, sir.
Thank you, sir.
Sir, a 3 by 3 matrix is given, sir.
Okay.
For that, we have to calculate minimal polynomial, sir. But this is not a Jordan canonical. It is not in that form, sir. Jordan canonical matrix form, sir. We have to reduce and we have to find the matrix minimum polynomial.
Yes, we have to. From the characteristic polynomial, we have to check each possibilities. It is not in diagonal form, right?
Can I tell you, sir, matrix?
Yeah, please.
First row 2 2 1, sir.
Okay.
The second row 0 3 1.
Okay.
1, sir. Next row 0 minus 1 1, sir.
Okay.
For this we have to calculate minimal polynomials, sir.
Okay, you just calculate some. You will get some eigenvalues, right? X minus lambda 1 power some x minus lambda 1 x minus lambda 2 into x minus lambda 3. Of course, lambda 1 lambda 2 can be equal. You just try. Do you have the eigenvalue for this matrix? Did you calculate? Hello? Hello? Okay, let me calculate the eigenvalues. Then x minus 2 times x minus 3 into x minus 1 plus 1. This is nothing but x minus 2 into x minus 3 into x minus 1 plus x minus 2. This has to be equal to 0. This is x minus 2 times x square minus 4x plus 3 plus x plus 2 equal to 0. X minus 2 equal to 0. From this we get x cube minus 4x square plus 3x minus 2x square plus 8x minus 6 plus x minus 2 equal to 0. This is nothing but x cube minus 6x square plus 3x plus 12x minus 6 minus 2 minus 8. If you solve this equation, you will get some. Hello, are you there?
Sir, yes, sir.
Yeah. So can you tell me the characteristic, I mean eigenvalues for this polynomial? Roots? You have any idea?
Now I will solve, sir.
Okay. If each are distinct, then you will get the minimal polynomials also same. If suppose either there should be three possibilities: x minus lambda 1 whole cube, this is one possibility; x minus lambda 1 whole square into x minus lambda 2, this is one possibility; and third possibility is x minus lambda 1 x minus lambda 2 into x minus lambda 3, this is one possibility. In the third possibility, this is same as minimal polynomial. In the first possibility, you just calculate a minus lambda 1 to I whole square. If this is equal to 0 in the first case, if this is equal to 0, this is then minimal polynomial has to be x minus 1 whole square, x minus lambda 1. If this is not equal to 0, then minimal polynomial has to be x minus lambda 1 whole cube. If this is not equal to 0. In the second case, minimal polynomial has to be, you just calculate a minus lambda 1 times I into a minus lambda 2 times I. If this is equal to 0, then this is the minimal polynomial, that is x minus lambda 1 into x minus lambda 2. If this is not equal to 0, then x minus lambda 1 whole square into x minus lambda 2 whole, this is the minimal polynomial. In the third case, it is the polynomial is same as minimal polynomial. So we have to do two calculations here, this one and this one. From these two you can get the minimal polynomial.